Hi there, and welcome to this latest episode of Totally Unscripted. And I'm delighted today to be joined by our Velcro faces with Steve Webster and Bruce McPherson, but we're also joined by Zig Mandel. So Zig, I'm sure, is a name you recognize from places like Stack Overflow. He's a big contributor to not just Google Apps Script, but other products and services that Google have to offer. So welcome, Zig, to this show.
Thank you.
As usual, we're going to just kick off initially with just a kind of a look at what's in the news right now with Google Apps Script. So there's a couple of things that have come out recently. So this first one, Steve, I think you picked up on. I don't know if many people remember that you can actually develop add-ons for Android for the Google Suite apps of Docs Sheets. But you picked up this item quite recently, Steve. Is some more things you'd like to say to this?
Sure. Yeah, I noticed the article, and I just thought it was interesting. From 1 year from the announcement of having add-ons working through the Android operating system, there were no new apps available. And so I started a discussion on the Google Plus community for add-on. And so we did some of that. And you can read more if you visit the add-on community.
I did a presentation not too long ago for the Edinburgh Mobile Development Group, and I basically told them avoid add-ons for Android add-ons for AppScript, because I just didn't think the implementation is really there. But we've seen with the Gmail developer preview that where the add-ons are actually implemented differently. So that looks more promising, and I think we previously talked about how we very much see this new model that they have for Gmail add-ons as the way forward. So, and I think as well, Steve, you were mentioning that it's very easy to develop responsive apps as well. So there's lots of other solutions for this. But
yeah, Gmail does look good, except I'm concerned about not being able to override the UI. Because some add-ons can be very complex, and the out-of-the-box UI experience that they're using this card stuff may not be good enough. So that's
yeah, we'll see how that one pans out. So moving on, so this was another one, Steve, that you picked up. So web apps and add-ons whitelisting. Do you want to talk a bit more to this one?
Sure. So on one hand, we've always had for a long time now the ability, let's say with add-ons, to say, I want to publish my add-on so it's on the Chrome Web Store, if you will. So if you're in a Google spreadsheet, for example, you can browse add-ons. But it's also possible when you publish to have a little check mark to go to the marketplace. Then when you're the administrator for a company or a domain, you can whitelist these third-party add-ons or web apps. And so that's been around for a while, but what's new is hooking it up to certain services within the domain. Am I allowing this app or add-on access to, let's say, the contact service? So there's another scrutiny of authorization there. I haven't fully digested it yet, but that's what it appears to be going on. And I've got some links here we can share after the broadcast.
Yeah, another interesting development, and as Steve says, we'll share out the links as well, so you can look at that in more detail. I think it as well, it kind of relates to the whole professionalization theme that we've got going today in terms of where AppScript is heading. So a couple of just other, I came across some really nice community contributions recently, and I thought I'd just flag these if you haven't seen them. So the first one's from Kanchi. So what was impressive about this, he's published a library which has image tools. So what the library does is it's able to extract things like image file type, dimensions. So if that's something you need within when you're developing stuff within AppScript, there's a nice library to do it. What really impressed me was he actually went into the DNA of the image file. So he was looking at decoding the kind of the raw bytes to work out file types, and so that was impressive stuff. So again, there'll be links after the show if you want to have to look at that. And everyone came via Ken Lane, who's API evangelist. So he highlighted some work people have been doing. Basically, with URL fetch, there's so many opportunities in terms of integrating into other products and services. So if you do need some machine learning into your spreadsheet, then there's more details on how you can do that. So really nice to see the community sharing bits and pieces, and if there's anything you spot in the community that you'd like us to highlight as part of the show, then feel free to ping us so you can get us on the Totally Unscripted page, and there's various contact forms and things like that. But without further ado, we've got Zig here, so and I want to give Zig plenty of time to talk about what he's got today. So as I mentioned at the top of the show, Zig's a huge contributor to the AppScript community, and particularly with what he does on Stack Overflow. But it's not just AppScript with Zig. He's very familiar with a range of products and platforms, and we thought we'd get Zig along and talk about some of the recent work he's been doing in this area. So, Zig, tell us more about what you've been up to recently.
Sure. First, you hear me okay, fine?
Yep.
All right. Well, I've been looking at Google Cloud Functions, and the primary reason I looked at it was, well, first, I know JavaScript pretty well. I learned it with AppScript, and it was natural, like the natural next step was to look at something that sometimes can be a little bit more powerful than AppScript, but it uses the same language. So it was pretty easy to pick it up. And I needed to do it, in my case, for a backend for Stripe. Stripe.com is a payment handler, and I needed to charge for a service. So I ended up doing it with Cloud Functions. So I'm gonna present a representation here on the screen. Let me see how I do that. Share screen. I'm going to share my entire screen. Can you see this?
Yep.
All right. So with this link is really the way for you to get started. I'm going to share this, the URL of the presentation itself as well at the end. Basically, it uses node.js, which is a whole different topic to talk about. I will not talk much about Node. But the great thing is that it uses JavaScript, and that was good enough for me to start learning it. Here is why you would want to use it. This is my top 5, but you can probably find more reasons. The first one is, well, handling a request. Just like in AppScript, you can have a do get or do post. You can also do this in Cloud Functions and have an on request, which can have and handle post, get, and any REST call, any HTTP or HTTPS call. One great thing about Cloud Functions is that you can map them to a custom domain, and you'll see why that's great in point 4 later. So number 2, respond to events. And this is also something great that AppScript doesn't have built-in really. The first one is events about the database. And this is also a big topic that very interesting that you should look if you haven't looked into Firebase database. It's a real-time database, and for example, whenever you or anybody or another app adds a node into your database, you can say, "Hey, call this function in my Cloud function," so you can react when a node is added or change it or whatever. And not just by you, of course, but by anybody outside of your app. The second trigger you can handle is authentication. That's also built into Firebase. You can have a login with multiple providers, including custom name and password. And so you can have a trigger. So whenever a new user signs up, maybe you want to send them an email saying hi. And the third one is for analytics. These are the new Firebase analytic events. And also they are better in some ways to Google Analytics because they happen real time and without aggregation of the totals. And you can react also real time with a trigger from an analytic call. The fourth one is cloud storage. Like if you or somebody else puts a file on a folder, you can your Cloud function get called. And also for the last one, PubSub. Also a great thing to look into if you haven't looked into it. It's like a way to store. It's like a queue where you can put stuff without having to react instantly, and then you can pull things from it. And also, whenever a message arrives to the PubSub, you can get a call into your call function, so you react. Besides push events, you can also register a webhook, which is the reason I did it for Stripe. So, for example, when a customer when Stripe fails to charge a credit card, then it calls a webhook into my Cloud function, and so I can email the user and say, "Hey, your credit card is not letting me charge you," something like that. And the fourth one is really a great one. I should be at the very top. It's you can make a backend for a front-end app. So Firebase also has Firebase hosting, which runs on top of Google Cloud Storage, and so you can have your front-end app stored there, like a HTML, CSS, JS app, but the backend can be in Cloud Functions. And because you can assign custom domains, you can avoid problems of cross-domain requests and such, because then your Firebase hosting app is on the same domain as your Cloud Functions backend, and it's just a regular, full-fledged app, web app. The fifth one is just is one more reason really. In my company, we tend to make Google Cloud Platform scripts for launching instances or doing batch operations, and we used to put them in Linux scripts, shell scripts, with GSU2, for example. But it turns out that sometimes it's much more practical to have it in a Cloud function, and then it's auto scales, etc., which is what we will see next. On the next slide, this is really the reason I wanted to give this talk, which is to compare it with other existing platforms. Mostly I looked into App Engine because that's what I was using in my company for big auto-scaling systems. And it turns out that many of them can be done in Cloud Functions, sometimes easier. So here's a comparison at the top of just like a raw potency that you can get on a single instance, of course. Right now in Cloud Functions, you can choose 5 potencies. You can see there the ranges of CPU and RAM, from 128 megabytes to 2 gigabytes of RAM. So that's pretty good. About concurrent requests, which is really the meat of this, is that you can, you can call concurrently your Cloud function, and Google automatically takes care of the auto scaling. that's something that we sometimes suffer in AppScript because we have time limits per function and per day and per concurrency as well. And this one is more, well, it's bigger. 400 concurrent requests is really a lot, unless you need something really, really huge. App Engine can do more, but not really, because if you see here my calculation, it says 1,600 concurrent calls, but that requires some tweaking in App Engine. For example, there is a variable in App Engine called max concurrent requests, which is how many requests a single instance can have. And you can put it all the way to 80 instead of 8, which means a single instance can have 80 threads created on it. And that means your threads will end up sharing memory and such. So it's not, yeah, you can scale it to 1,600, but each node will be to power RAM specifically. So in Cloud Functions, not so, right? Each of the 400 has its own instance guaranteed with the power that you specified when you chose your potency. Up to now, some comments or questions that you guys have?
I'm just, have you, in your experiences so far, hit into the limits of with Cloud Functions and the, I think it was 400 concurrent?
If I have reached them?
Yeah.
No. Well, in the case that I've implemented the Cloud Function, it's for handling licenses. So I would love to have 400 people try to purchase my app concurrently, but that doesn't happen. In my case, it's really more than enough, 400. And it's in beta, Cloud Functions. I should have started by that. So maybe they will make it more powerful later. But it's concurrent. You have to take that into account. I mean, your request can take only 50 milliseconds maybe to finish. So it's hard to have so many concurrent requests built up unless your function is taking a long time to finish.
So yeah, Zig, I got a question. One of the things about the App Engine is that if you're using the flexible instance, which you will need to if you're using Node, there isn't a free tier. So in other words, you're paying right away, and you're paying not for usage, but you're paying for existence. So it can be quite expensive. So if you had 20 instances, that would be like super expensive. But on the Cloud Function, you've got a certain some like, I don't know, 2 million calls or something that are free in a month, haven't you? What's the? Do you know what the number is?
I don't know the number by memory, but I looked at it and it was huge for my case, for my usage. It does have like, I have my app for a few months already online, and with many thousands of users. The Cloud Function is not only used for licenses, it's also used for other things. So many users are using it every day, like every second I go in there and people are calling the functions. And so far I haven't been charged.
Okay, that's good. As I say, I mean, App Engine can cost you, 50, 60 bucks a month, and you don't really do anything with it. So I haven't paid
a penny. And I'm using storage, functions, triggers, many things, database too. But that's what you mentioned is inflexible, because in App Engine standard, you have also a very lax quotas.
Yeah, that's right. And if you're using Java or Python or something like that, then you get loads of stuff for free. But for some reason, they haven't done that in the Flex environment.
Yeah, I mean, that's because they haven't. Eventually, I think App Engine will become just flexible, and then everything will have. Maybe the quota will go away, but they can't. It's a language thing. The platform they have only works on Python and Java. Well, and Go. What else here? Well, yeah, it's important what I say, right? Put the right weights for your needs, because you cannot just say 1600 is bigger than 400, so App Engine is better, because in the App Engine case you are sharing RAM across many threads if you really push it to that limit. So in reality, App Engine is more like with a standard limit of 8 threads instead of 80, you have to divide by 10 the 1600, so you end up with 160 concurrent calls if you don't tweak that. So that's less than 400. So it's, you know, it's hard to say which is better, but both handle very well the concurrent requests, and also the response times, which is also something that can help you compared to AppScript. In AppScript, you have sometimes 5 minutes, sometimes 6 minutes. I'm not sure which is which. I think it's 6 minutes now, maximum time for a single call, while in Cloud Functions you get 9 minutes, and it's really great. 9 minutes, especially compared to App Engine, which gives you 1 minute. So sometimes 1 minute, many times is not enough, and you have to play many tricks with. No, you complicate things in App Engine if you need more time. So that time for that, Cloud Functions is great. And also in App Engine, there's also response times for doing like a fetch, like in AppScript. Also, you're like there's so much time that Google will wait for a fetch, and in App Engine too, and not so with Cloud Functions. You have more control with that. The next thing I have is a little screenshot of what you get from Firebase. It's important to note that if you're starting on Cloud Functions, there's 2 ways to start. You can look at the Cloud Functions documentations from Google, or you can go to firebase.google.com and look at it from there. And in Firebase, it's much better. It's integrated into their database and their triggers, and you can do more from there than from the Google Cloud Platform documentation. So here you see that there's a Functions tab on the left, and it shows you the functions that you have launched. And it also has the next panel. Really at the top, you see it's in Spanish, sorry, but it's control panel, and then your logs, which says registros here. Logs is automatic logs, like whenever the function is called, but also if you do console.log and put whatever there, it ends up in this log. And this is really great because you can connect it with Stackdriver and do something like whenever a log with level error or it contains such and such string, email me and check it every minute. And so if I put errors in my console, I don't have to do anything special. I just get an email whenever something weird happens. And it has helped me a lot to debug things and to catch things very quickly before the user notices if there's a bug, for example. So that's what I have for Cloud Functions. We can really talk a lot more about it, but I think it goes a little bit off the topic. If you have questions or comments, I'll be happy to answer them.
Hi, this is Rudy in Dallas. I was just wondering, what was that difference in the 2 links of accessing Firebase?
Between, let's see.
Accessing it on Google Cloud versus accessing it directly. Oh, there it is.
Yes, this link, firebase.google.com, get started, is the one that I recommend. Because if you go, let's go to it. First, it's really well done. The explanation of the steps to install Node and everything. I really didn't know anything about Node, and this page was all I needed to get started. Within maybe 2 minutes, you can have, well, maybe 5 minutes, you can have a Cloud Function deployed and working if you start from zero from this page. There is also the if you just Google it, what you get is this, and this is more confusing. It's like the standard format of Google documentation, but like you can hear, and it's not that easy to get started, really. I mean, it has quick starts. It has maybe some advantages, which I haven't tried yet. In particular, there is a code hosting in Google, and I think you can host the code and run it directly as a Cloud Function if you deploy it from this console. Like there's a Google console and the Firebase console. And once you deploy it on one, you can't switch to the other. Okay, so that's why it's important to start on the right one. I think it's easier to start on the Firebase one, and it's more integrated with what I needed. But there might be advantages to the Google console, which I haven't identified yet. And I think I suspect that the code hosting is one advantage that Firebase doesn't have.
So we covered Google Cloud Functions last week. They are a little slightly different than Firebase ones, and you're right, Firebase is a lot easier to get started with. On the Google Cloud Function, you've got an entire GitHub type of an environment that you can use to manage and post code.
Yeah, that's what I was suspecting too, right? That you have the code hosting, and once you host it there, you can just deploy it from within there directly, I suppose.
Yeah, and not only that, you can also integrate it with the public GitHub if you want, so that if you make a change in your public source code, it automatically refreshes back into the hosting environment within Google Cloud.
Okay, yeah, that's a really great advantage. And if you need that, you won't get it if you install it from Firebase. In Firebase, it's more like using command line tools to deploy. Like you say, Firebase deploy, and the folder, like let's say, like really, if you see my desktop, I have this is it, right? I have a folder called functions, and in there I have an index. And then if I go into my command prompt and from this directory and say Firebase deploy, then it just puts the code in Firebase. So it's easy to work with, but I guess it's easier if you integrate it with code hosting directly.
The other thing that you get on the Google Cloud Function side is you have a built-in virtual machine that you can use for playing around with, and before you send your code up to be a Cloud Function. And you've also got an simulator, so you can run it locally, well, sort of locally, without having to deploy it. I don't know if you've got that in Firebase as well.
Yes, in Firebase you also have a simulator.
Okay, yeah. Okay.
But I haven't used the simulator because what I do in Firebase, and especially because it's the free tiers, is you create a separate project for like your beta or your test project, but completely with a different console and everything, and deploy there and test there. Because at the end, you have to also call third-party functions, and when it's hosted locally, sometimes you can't. So I just don't bother with hosting locally and use a separate console.
It's actually not local. It's running on a virtual machine, but it's sort of local.
Ah, because the Firebase one does make a server on your machine and runs it there.
Okay.
Okay.
Well, if you want to find out more about getting started with Firebase functions, the session we did last month with Rio, we turned into a tutorial as well, so it does the whole step-by-step setup that you need for that. So you can get started there. Was there anything else you wanted to add, Zig?
That's it.
Well, it actually, I think, leads on quite nicely to our next set of presentations. In fact, the whole, we're talking about deploying, keeping code, that sort of thing, and managing. We're got Steve is going to talk next about the professionalization of Google Apps Script development, and as part of that, when we mentioned this on the Google Plus community about this session, we've actually got Bruce and Rudy who are going to contribute a bit as well. So I'm going to hand it over to you, Steve, first, just to get the conversation going, and then we'll bring in Bruce and Rudy, and hopefully Zig, you can stick around because I know you've got a lot of expertise in this area and you might want to contribute as well. But over to you, Steve, first.
All right, thank you. Let me share my screen.
Good morning, Sean.
Okay, can you see my screen okay?
Yeah.
Great. Okay, so we have Google Apps Script, and by default, we are in Google Drive, and we can create a new Google Apps Script where it's a standalone. So let's talk about standalones versus contained scripts. So let's move on. So what we're going to go through here in about 15 minutes is we're going to talk about Google Drive folders where we can have like a production or test folder, and then you can have another folder for developers. So in this case, we're talking about what if you're doing an add-on and it's very popular, and now you need a team of developers to help to maintain one or various add-ons. So this is a team environment. So we're going to talk about what is GitHub briefly, and then we're going to introduce a Chrome extension that supplements the existing script editor IDE. And then we'll have a setup GitHub to become master source in that Google Drive. And the point there will be, instead of your source being within Google Drive, we're actually going to use a version control software of GitHub. Then we're going to have each developer push to their GitHub branch, which I'll explain in further detail. Then once that's done, you can merge it with the master. And if there are any conflicts among the developers, it can be reconciled there. And then once that's done, we want to have a separate instance for a production or a test version, if you will. So in that case, you open up another copy, another instance of that Google Apps Script. You want to pull in from the version control software from that master. And then finally, you just do your normal Google Apps Script publishing. So let's go through some of this in more detail. So keep it in the cloud by creating folders in Google Drive. So one simple way of doing it, okay, I'm going to have a production folder and a list of developers folders. Now, it is possible to have the developer folders independent via another account, but let's just go with this. So then the developers could be someone like Bruce, Martin, myself, or whomever. So there's this like management of version control. And so we want to have these buckets that are separated is the point here. You could have maybe a production environment. You could maybe have a test folder for QA purposes, and then the raw development of the code too. Okay, so what is GitHub? Well, you can see here that we're going to focus on the part of the GitHub of its version control repository. It handles things very nicely. It's widely used. In fact, I think Google themselves use it. So that's what we're going to focus on. And we're going to show you how to interact with the script IDE with this version control software. So the way that is done, someone has written a very nice Chrome extension. It's called Google Apps Script GitHub Assistant. And we can provide the link after our broadcast. And once you click that link, it'll be a quick, easy install. And then what you'll notice is when you open up your Google Script Editor, the IDE, it will now have a supplemental menu options. As you can see here to the right of the select function, you'll have a repository, branches, the ability to push or to pull from. So to set this up, we want to, again, focus on the main point here of what we're saying. Google Drive is not the hosting, it's not hosting the master source copy, but version control is, right? So we have to have that mindset that the main source, the Bible, if you will, is the GitHub repository. So that's where we trust where all the versions are, and especially our master, okay? So you can use the script IDE to set up a project in GitHub by using the repository branch, which is interesting. So you don't have to spend all your time in GitHub to setting things up. You have some ability to do it within the script IDE itself. For example, in the screenshots here, you could create a repository by clicking the drop down and click create the new repo. And then once that happens, you have a pop-up. You can enter the name, description, and if you want public or private, and create. And in a similar sense, you can do the same thing with branches. So each developer could create a branch that is designated for them. So that's what can happen there. Okay, now each developer can push to the designated GitHub branch. All right, so in other words, a developer has their own copy of the latest source. Then they make edits, and next they need to push the entire code to the GitHub or version control software. So in this example, I have like Steve version 2 in the screenshot. So once I make my edits to the code, and while other developers are editing their stuff, what I can do is to say, okay, I'm done with my task of maybe adding a function to my code, let's say. So at this point, we want to push my branch up to that version control software of GitHub. Now, I do want to make a point here, as you can see in the last sentence here, that once you've done that task, and then you're assigned another task of that source, let's say you have to add another function. Well, you want to make sure you're in sync with the master. So in that case, you say, okay, I'm going to open up my script. I'm going to assume there's been other merging and things like that with other developers. I want to make sure I get the latest code here. So you can click pull from the master to make sure you have the latest instance of the live production environment, let's say. And now when you make your edits, you are confident that you're not going to overwrite anything. Now, once you go through and you push let's say you added that function to the source code and you pushed it to your branch, there's now work involved to say, well, I want to sync that with the master copy. And this is where the GitHub version control is very nice, right? You can say, okay, I want to compare the master with my particular branch. So you choose your branch, and then I'll do a demo of this in just a moment. And then you go through a few clicks, and then you're done. Now, if there are any conflicts between your code and another developer, which could happen, right? You can resolve those conflicts right within the GitHub software. Okay. So now let's talk about a publisher. So again, we're talking about a team environment of developers. You can have more than one person playing a role of the publisher, but let's define what I mean by that. It's the person who is responsible to copy or migrate or publish to the live production or even test instances. So yes, you could say each developer, you have to do this, or you could say, no, I want more control in this situation. Maybe I want to wrap it with a change management process that I may have. I want to have a designated publisher. So it could be an independent person. So for example, here, if Bruce and Martin complete respective code edits and were merged to the master in GitHub, now it's time to pull the changes into a test or live instance. The publisher, let's say maybe I'm playing that role, would open the Google Apps script within the production folder, which is a separate instance, right? And pulls from the master. And then I would just simply perform the normal publishing process that comes out of the box of Google Apps script. You could publish the add-on or a web app. So before we go into questions, let me do a demo. So here we have my production folder and developers folder. And I'm one of the developers, Steve. So let's open up my sample project here. And let's say I want to add a new function as my task. Okay. So I just made a change. So I'll click Save. So now I want to make sure I'm going to the right repository, which project. I want to push it to my developer instance, that branch. I want to push it up to the GitHub repository. It shows me the differences as a confirmation to say, yes, that's what I did. I can enter a comment, click push. Then I get a confirmation. Now at this point, let's say each developer is responsible to do the merging with the master. So then the developer would open up their GitHub. And this could be private or it could be public. In this case, with GitHub, you can pay a service. I think it's a $7 fee per month to be able to have private repositories. So here I have the branch master. I want to do a pull request. And I want to compare with my branch. And then it brings this up. It's able to merge. And I simply click create my pull request. Now, if there's any conflicts with other developers, this is where you can use this software to resolve the conflict. So you can learn more about that on your own, but this remains focused on here. So now we just say merge pull request and confirm, and we are done. So now let's say I'm going to play the role of the publisher, the person who is responsible of getting this update to the either test or live production environment. So let's say we're doing the live production. So this is a separate instance of the source code, separate from the developers. So in this case, I want to open that. Actually, it looks like I used the wrong sample project. I was supposed to do dev, but we can still continue. So let's pretend I did this correctly the first time. So I open up this. So this is the production one. And now we want to pull from the GitHub into the production one. So we will choose master. I want to pull that in, but of course I have done this out of order here, so I apologize. So let's click pull. It says, okay, I'm going to add a new function. I'm going to pull that in. Then it refreshes the screen. And so this is really, really nice because let's say you have dozens of files here. It's going to update all those files that quickly. So now we're just wrapping things up. It's time to go ahead and deploy it as a web add-on and follow the normal publishing procedures or the web app, what have you. So that's basically it. And are there any questions?
It's great to see you talk through the process. I know we've got some people watching as well. See if there's any comments from people asking on that front, or from the Hangout as well.
Looks like a great integration. Awesome.
I use GitHub a lot myself, and it's a Chrome extension I'm very fond of as well. But I suppose that leads on nicely. And I'll just pause. In fact, I'll keep talking. If everyone's got a question, they can jump in. But it leads on nicely to I think what Bruce is going to talk about for the next 5 minutes, where one of the nice things about GitHub is it has its own API. So as well as Steve was doing a very manual process, it is also possible to automate the processes as well. So Bruce, I don't know if you want to take it from there, or if we lost Bruce.
Yes, I'm still here. I'm just doing my usual mess. Hang on a second.
Was more time for questions?
I have one question about the Chrome extension. Being a Chrome extension developer myself, I wonder how often it breaks when Google changes their HTML or something.
I did take a quick look before the presentation. Actually, I think it was last evening. And the developer of the Chrome extension is very active of making changes. And it seems to be being well attended to. So far, so good for that.
Another question from Faustino is when you pull files from the Git repo, is it going to pull all the files or just the files that a single file?
That's a good question. It will pull all files. So if there are 10 developers and you all did different things and you want to update your main production source, you want everything to come over. So it does all files.
Okay, I think Bruce is all set up now. So
yeah,
Bruce,
can you see my screen okay?
Yep.
Okay, so I'm going to talk about automating that bit. I mean, I use that same Chrome extension, but I have a slightly different problem in the sense that I have a lot of stuff that I share, and sharing can be quite time-consuming and hard. On my site, I have 1,000 pages of tutorial, and that the code for that is in 160 different repos, and those repositories use 50 different libraries. So juggling all that stuff manually would be kind of a nightmare. And obviously, if I update a library, I want to make sure that the project that uses that library has got the source code of the library as well as its own source code, so there's no dependencies that are needed. You know, so you don't download a project and then find out you need libraries that you don't have and everything. It's all in the same repository. So this is what I'm trying to juggle. So I have something that runs every day and automatically does all that. So we'll just take a quick look at that. The steps are, first of all, it does an extraction, which looks at all scripts that I've published, which are in a particular directory, as you can see a snip of it here. And it takes those scripts, those Google Apps scripts, and extracts out from that all the scripts that are within it. So each project will generate multiple files, usually quite a number of files. The next thing it does is to resolve the libraries that are being used by those projects. So if I'm using one of my libraries in a project, it's going to go off and find out where that is and where its source code is as well. And it's also going to create an auto documentation of the dependencies for a project, which we'll look at in a minute as well. And then the next step is to take you can see this last column of file names. These are the scripts that have been pulled out of a particular project. And I then want to automatically push that to GitHub for each of the 160 repositories that I've got going at any one time. So that's the steps. And of course, that's just one thing, one trigger, one app script trigger that runs every night to do all that. So, and the auto documentation, we'll look at the actual one in a minute, but you can see that in GitHub itself, it creates a list of all the dependencies for a particular project, what the project key is, the version, and all that type of stuff. So that it's easy to see everything that's being used by a particular project. And it also looks at which advanced services, Google services, I should say, that are being used in that project and documents them as well. So that if you happen to want to set up a brand new project, you've got all the data you need here to be able to do that. So how does it work? Well, in my nightly trigger, I've got various settings that say where to look for scripts that are published, where to put them to. And then I've got a few other things that are needed for automation that are not that relevant. But my trigger batch program, you can see on the right there, it's three things. It's do the extraction. In other words, pull out all the files from each project, do the libraries, which is to find out which libraries are being used by any project, and then do Git, which is to push it up to GitHub. And down at the bottom, you've got the contribution history of this stuff. So it's 4,800 contributions in the last year that have all been done automatically without me even really noticing. So another good thing that it gives me, of course, is I can, since I've got all those files available, I can do some visualization of dependencies and so on. So this is an app script app that's looking at, what is it? It's an HTML service app using d3.js, and it's looking at all my projects and it's looking at all the dependencies. So for example, if I wanted to see, I don't know, any one of these things, take that one, I can see that this particular project is using those 5 libraries. And then I could maybe pick a library, that one. It's only using one, let's get a different one. That one, say, and I can see all the projects that access that particular library. So as a kind of a side product of having done all that stuff in GitHub, I can now do all this kind of things to dig into things that are related to each other. So let's have a quick look at the GitHub repository. This is the repository for the actual software that we just looked at, in fact. So it's always got the same format. It's got libraries. This is all the code for all the libraries that are referenced by this particular project. So this is completely standalone. So it's pulled in the latest versions of all the source code for the libraries it looks at. And the other thing it's got, of course, the scripts is for the project itself. So these are each one of the projects in the IDE. But very handily, it's got this dependencies file, which it's created automatically as well. And it's going to tell you all the script files that are in that project. It's going to tell you the references that it references directly. And if you want to, you can go and have a look at the source code there, what the versions are. And then it's got other dependencies, because of course those libraries themselves might access other libraries. So it's got those things shown here, and it's got whichever Google services it's using. So that's kind of it. It's really maintenance free. I really just don't have to do anything much to this at all. The only thing that happens is that occasionally Google changed their dependencies, how the dependencies work, because the way, if you noticed, it went off to figure out, happened to be using the Drive Advanced service for that. It had to go off and find out into the inside of Google Apps Script IDE to find out which ones were being referenced, and they change that from time to time. So that sometimes you need to do a little bit of a hack to figure out how that works when they change it. But aside from that, it's fairly maintenance free. And the final thing is that if you want to, you'll notice that of my 3 steps, the last one was to push it up to Git, this do Git. If you want to use the Git client itself, as opposed to automatically doing that, then you can just run, instead of doing that, you can do a Git push in the normal way that you would do if you had been doing this manually. And that's it. Any questions? Anybody there? Yeah, here we go.
It looks great.
I think there is general wonderment at what you've been able to achieve, Bruce. For me, you've been able to visualize your dependencies as well. I think is ticks huge boxes for me. But
yeah, but having said that, the doing that kind of stuff is really quite easy if you've got the input files that allow you to do it in the first place, because each project starts with a thing I call info.json, which describes the project in mammoth detail. And then you can just use that to visualize. So I'm not actually looking at when it does that visualization, it's not really looking at the projects, it's looking at the info.jsons for every project.
So is there much in terms of the info JSON? Is that something that you manually have to write yourself? Or?
No, that gets created automatically as well. The only thing you need to do is that small setup that I showed you in one of those slides that said where your files are.
Yeah.
So where your files are, and how to log into GitHub, and you're done.
Impressive stuff. I think it's nice as well to see the two different approaches here that Steve was talking about at managing a team environment where you're working on code together. I suppose with your example, Bruce, it works because you're the single developer. So
well, actually, I use Steve's method as well for when I'm developing, so that I can have test and development and all the rest of it, even though typically I'm the only person working on it. But then once I've got a production version, that goes into my published script. My published script place is the equivalent of production that Steve was showing, and then that's what automatically gets replicated to those repositories, not the working stuff, if you see what I mean.
So Rudy, I know you mentioned before the show that you had a quick 5-minute presentation. Do you still want to do that now?
Yeah, I'm good to go.
Yeah, so we'll just if you just want to get set up, Rudy. That's great. I can see you sharing your screen.
Okay, you ready?
Yep.
And you can see that?
Yep.
Okay, this is the presentation I wish I had a year ago. A year ago when I got started. If for anyone new out there who might be listening, I have 3 key messages for you. 1, you can definitely do this. 2, this is a good way to start. And 3, check out the link at the end of the presentation. First off, here's a good reading list to get started with, especially item 2. It's very deep, and it comes from the folks at ZenHub. And if you went through this and you did some homework, you played around and experimented, you might end up with this basic stack for doing your own dev flow. So I'm looking at doing Google Sheets add-ons. And then again, you'll see some of the same concepts that were mentioned earlier, where you're using GitHub to host the origin or truth repository. You're using Git flow. So inside of that origin, you have a master and a develop branch that you're always using. And then you're following Git flow rules for making updates, which means you're creating separate branches and merging them into develop and then putting them into master, following some conventions that have worked for a while. Let's see, ZenHub, basically it integrates natively with GitHub's user interface. It's a layer of planning without the context switching. I think it's very good. So far, so good. The work you do locally, if you're working locally, I like to use Atom. It's a hackable code editor. I think for other reasons, people might want to use Eclipse because it's better integrated. And then Git Kraken, which is a Git GUI. It's really fabulous. Let's see. Then if you're working in the web editor, as we saw earlier, so these presentations are complementary. If you're working in the Google Script Editor, you want to use the GAS GitHub Assistant to interact with your remote repository. What does it look like? Let's look at some screenshots. Here's Git Kraken on Mac. You see that the branch history is, first of all, it's visual. It's oriented vertically with the newest on the top. And on your left, you can see what's local. You can see what's remote. And then you can see the tags that have been applied. And then also you see that Git flow. They have a Git flow layer. So you can start releases, hotfixes, or features. Let's see. Oh, I did want to mention the cost is very low. You could do it for free if you're using public repos. If you pay a little bit of money, you can have private repos, and Git Kraken will let you manage merge conflicts inside of its tool. Here's a Zen board, or ZenHub's task board. I like to call it a Zen board. It's they have 7 default pipelines that you push your issues through, and you can learn all about that. It's sort of a post-agile scrub approach. Moving on. Oh, as you can see in the top here, you see boards. So ZenHub literally is a Chrome extension that injects its functionality inside of GitHub. So it's seamless. It feels like it's part of GitHub, which is a very interesting approach. The next one is, this is a look at the Atom editor itself. It can interact directly with your repos, or you can manage all that via Git Kraken, which is what I do. This was just talked about. Next slide. Here's a list of practices that you want to employ. More or less, the overall approach is that you're using ZenHub task boards or Zen boards instead of GitHub projects. You're using GitHub issues as if they were work tickets or user stories, and you're using GitHub milestones as your sprints. Let's see here. You want to, key things to make it work. You want to have a label scheme that goes beyond types. You might want to do some automation to standardize some naming conventions, and you want to implement some templates as well on GitHub. Here's the label scheme I'm using right now. Probably the highlight of it, two things. There's a tool, a link to a tool that allows you to copy labels between repos, very handy. Probably the thing I like best about my own label scheme is that there's a set for complexity. So I associate t-shirt sizes, which is a borrowed idea, and then I put ranges of story points. So story points are ways to estimate that are unitless, because people are better at comparing relative sizes. And then ZenHub has injected in your issue a milestone field for you to actually put what the estimate is. This is how ZenHub runs their backlog of issues through their pipelines. And you'll notice that your product backlog would have, once it has enough detail, it floats up to the top in priority and detail. Once it has an estimate and a milestone, once it's been assigned to a milestone, you're basically running a sprint. Somebody working on it pulls it into progress and keeps working. Here's an example what the semantic versioning would look like. More on that later. Things to watch out for. Well, I would say one thing about semantic versioning. I like to use it in my commit titles because it's really handy to follow. So not just the major releases where you have like x.y.z, right? I go dash the change topic and then dot iteration number. And so that works whether it's a hotfix or a feature. And when I see them in the commits histories, it just sort of orients you. There's a list of things to watch out for, like merging Zen boards. Stuff we didn't talk about, closing issues, some gotchas, a few notes on releases, and versioning, which is an important note. Basically, we'll get into that another time. What's next? Go to this repo, and you'll find the starter templates that are in there, the label scheme that I mentioned. If you star and watch it for ongoing updates, what I think I'm going to do is update this DevFlow repo to maybe also do demos or something in the future. And then as I do that, I try to model what the DevFlow looks like. So that's a public repo, and then the slides are up there. There's a PDF link. You can download it, and all of the links that were listed are live. 7 minutes. Any questions?
Perfect. I think it adds another lovely flavor to how you can approach this, and it's clearly a topic that you've spent a lot of time getting to grips with. I wonder if Steve, Bruce, you have any comments?
Yeah, one of the things you'll find with GitHub is that because everyone uses it, regardless of which language they're using and everything else, like zillions of people use it, there's massive amounts of add-ons and tools and everything else that you can use to make your development experience wonderful. I think it's, if you're not using GitHub, then you really should. It's quite hard to get started with, and I would say that if you introduce too many tools at the beginning, before you realize the fundamentals of GitHub, you might get a little bit confused. So I would say start slowly, get to know GitHub, and then add some of the wonderful tools that are out there to organize your life, as Rudy has clearly done.
Steve or Zig, you got anything to add? Or Rudy, do you want to just respond to Bruce's comment?
Yeah, that's fine. I just I would definitely like to model later, like how I'm keeping my semantic version inside the code, and then how I'm using that everywhere else. Like in analytics, it writes to it. How I'm managing that and what it looks and feels like, because it's I think if people can see it, it's a lot better. So I wanted to sort of slice the cake all the way, and so I hope this repo would be a way to evolve, exactly formalize what I think is a workflow for me, and it helps me move on to more stuff. So I appreciate the time, and if anyone takes a look at it, star and follow my first public repo. Thank you.
We'll be there.
Zig, I saw you unmuted your video. I didn't know you went.
Yes, no, you just, so I thought it was great. I will look at it into detail and try to start using it because it looks very, very helpful.
Cool, thanks.
And it's awesome that it's integrated into that people.
Thanks.
And I would add, when I thought of this topic for today, it's one of those things, let's continue the conversation. So there's a lot of people leveraging GitHub with things like AppScript, for example. So please give us feedback, and maybe on the next episode, we can share some of those other processes that you have. So thanks.
I have one question for you, Rudy. So you mentioned Git Kraken, I think, now as a desktop tool. So I use the GitHub also have, I certainly know for Windows they have a desktop application that you can use that puts a nice kind of skin on this. Did you look at the official GitHub offering before choosing Git Kraken? Is there anything in Git Kraken that you think aces it?
Let's see. You're talking about the GitHub desktop?
Yeah.
Yeah, what I liked about it is that I could just click and open my repo directly from it, right? But I find that that Git Kraken is much more powerful. It's basically Git. It's a visual version of Git, and because I was intimidated by the command line of Git, and it took me some time to kind of appreciate what was going on with Git. But that's why I really appreciate like the reading that I listed. If you go and read, Git flow was something that guy was using, published a post in 2010 about, and you start to see it, become popular, and you just like step back and think about the concept, and then look at the tool. It starts to make more sense. And I'm still trying to shake out my dev flow too, right? As far as the versioning goes, but for me, as somebody with a process background, it's all about reducing the friction and improving the visibility and some of the standardizing the way you're using things. Like maybe in another session I'll show, I put some code in there where you can sort of make your code ready for testing. So say you open up a new sheet, or excuse me, a new script, and you pull your work in there, you could make it ready, and it will apply your standards to naming of the script and grab you a default sheet using the same name, so that when you publish to test as add-on, right, you're doing this cleanly, and it's really easy to clean up after yourself. You could also put like base cases of data, for example. But to your question, for me, I like to get Kraken better, especially after I realized, once I double click on a head, so I'm checking out and moving the head to a particular branch, I just swap over to Atom, and that's where I'm at in Atom. So it works pretty well, although I haven't been able to really use Atom to actively code and get feedback from the compiler on the if that's the right word on the Google side. But it works out because, right, I push, if I'm working on a feature branch, I push it as was demonstrated earlier. I push it to the cloud editor, right, and then I make changes there. And then if I'm happy with them, I increment I iterate my semantic version, and I push that back to the branch, which is temporarily pushed up to the origin. And it really works for managing changes.
Does Atom have the autocomplete I think I saw a request for this a long time ago. Is that there yet?
The autocomplete? No, it's not. As far as you mean autocomplete in the namespacing of Google's API services? No, it's not. I do remember a long time ago when I was looking at this, I saw somebody mention that you could download it. Download it and use it. It wouldn't be always perfectly up to date, but it'd be good enough for autocomplete. But I haven't seen an answer to that.
There is something available in Eclipse, I think, that as a plugin. So there is something that could be, that is packageable. That the Eclipse one Google developed and released. But I think, as Steve says, this has been a really interesting conversation to start, and I think it would be good to continue it. Unfortunately, I'm conscious of time, so and I'm on holiday coming Monday, so I've got to edit this. So what I think I'll thank Zig, Steve, Bruce, and Rudy for your contributions to this week's or this month's episode. And we've already got the next episode of Totally Unscripted in the block. So we've got another, I think, hopefully stimulating and inspiring topic. We've got Waka Ahmed, who's been doing some work with API.ai, which is a way to create conversational intelligent apps. So to actually, through voice or text input, do wonderful things in terms of getting input. So anyway, there's more details about that show on our Totally Unscripted website. Hopefully you can tune in. That'll be on August the 4th at the same time. We've got another vacant slot for that session, so perhaps we'll revisit this whole theme here of professionalization. With that, I think we'll call it a day. So thanks for tuning in.
Thank you, Martin.
Thank you, Martin. Thank you all.
Thank you.
Great session.
Thanks.